It's a very, very simple part, right? See, you have to understand that there is one thing called as electrolyte. So when you call something as an electrolyte, electrolyte would mean what? Electrolyte would basically mean electrolyte would basically mean that anything which can produce its ions, anything which
Yes.
can produce its ions, right? Either in the molten form, either in the molten form or in the
Aqueous.
aqueous form. Now understand. So when we say that something is an electrolyte, so electrolytes can be an acid,
Yes.
it
Yes,
can
ma'am.
be a base,
Yes.
it can be a salt. So electrolyte can be an acid, base, or salt, anything, right? All
Yes.
that is required for an electrolyte is to produce its ions. Now, understand, when this happens, right? So when this happens, so electrolytes can be this. Generally, we classify acids, electrolytes in the form of weak electrolytes, and something are called as strong electrolytes. So when I say that something is a strong electrolyte and then something is a weak electrolyte, what does that mean? That whenever something is a weak electrolyte and whenever something is a strong electrolyte, what does that mean? That ma'am, weak electrolyte means that if I am taking 100 molecules of some acid, base, or salt, 100 molecules of what? 100 molecules of
Acid base.
acid,
So
base, or salt. So let's say if I take CH3COH
I'm
and
only
I take
partial.
100 CH3COH molecules, understand?
Yes.
So I am expecting all of them to break down because if CH3, COOH, if this bond breaks, why is that bond breaking? Because O is pulling the electrons towards itself, and H electron is also being pulled towards oxygen because oxygen is more electronegative.
Yes, ma'am.
So as a result, whenever this bond breaks, so this bond breaks. So we were expecting that 100 out of 100 molecules, all 100 molecules will break down. So when all 100 molecules break down, what do you think we'll get? So this is going to break down in the form of CH3, COO negative, and H positive. Are we understanding? So we were expecting that out of this 100 molecules, 100 ions of this and 100 ions of this shall be produced. Are we understanding my point?
Yes, ma'am.
So this is the basic part. So when we are dealing with the electrolytes part, I hope you're understanding what does that mean, right?
Yes.
But what exactly happens? In reality, only 5 or 10 molecules will break down. That means 90 molecules shall remain undissociated and 10 molecules here and 10 molecules here. So we'll have the 10 molecules here and we'll have the 10 molecules here. They will remain undissociated. Are we understanding my point or not?
Yes, ma'am.
Are we understanding? So the
Yes, ma'am.
idea here is what? So the idea here is what? That whenever we have this CH3CO negative and H positive, what does that mean? That ma'am, this is going to be a weak electrolyte. That is, it does not dissociate completely. It does not dissociate into its respective ions completely. Got the point? But
Yes,
whereas
ma'am.
if you take an example of HCl, so if you take 100 molecules of HCl, I'll also explain you why this is a weak electrolyte and why something is a strong electrolyte. But let's say you say HCl is 100 molecules I take. So HCl is a strong electrolyte. That means it is able to break down into 100 and 100, and only zero undissociated particles of HCl shall be left. That means when we are dealing with HCl, so only zero HCl particles are left here. Are we understanding?
Yes, ma'am.
So that's the basic idea. So whenever we are saying that HCl is there and HCl is breaking down to form H plus and Cl negative, what does that mean? What does that mean? That HCl here means what? That it is breaking down into exactly 100 H plus ions and exactly 100 Cl negative ions. That's what HCl is. Now, why does this happen first of all? Just see. Let's say I have a beaker, right? And if you are clearly aware of the fact that water is a polar molecule, because the structure of water is like this, right? It's a bent structure. O
Yes, ma'am.
carrying two lone pairs. I'll also explain the structure, don't worry. H carries a delta positive charge, and O is basically doing what? It is pulling the electrons towards O and towards H. Towards O and towards H. Are we understanding my point or not?
Yes, ma'am.
So here, what exactly happens that H carries a delta positive charge here, and H carries a delta positive charge here. Got the point?
Yes, ma'am.
So here, what exactly happens? That whenever we are dealing with this H2O part, what does that mean? That ma'am, when we have HCl, H plus HCl, so there is a charge on Cl negative, and there is also a charge on H plus. Yes or no? So when
Yes,
you
ma'am.
have water molecules, what does this water molecule do? This water molecule shall pull the electrons towards itself because water molecule has two ends. One is O, one is H. O is highly electronegative. O wants to pull the shared pair of electrons towards themselves. So O is kind of pulling its own electron as well as hydrogen's electron. Thereby, it is not carrying just its own electron. It is also carrying the hydrogen's electrons toward itself. Thereby, O carries a delta negative charge. Are we understanding my point?
Yes,
So
ma'am.
this H also carries a delta positive charge, and this O also carries a delta negative charge. So in water, if you add anything, any molecule, and if let's say that molecule also carries some charges, so then what happens that around the positive charge, the negative end of the water comes here, and around the Cl negative, what happens? We'll have this
The
part, yes or no?
yes, ma'am.
So this H plus of the water molecules and O negative of the water molecules is trying to pull apart H plus and trying to pull apart Cl negative, and hence this bond kinds of break. Are we understanding my point or not?
Yes, ma'am.
And when this happens, so this is going to break down into H plus and Cl negative. Now, if this bond is if this bond is very weak, HCl bond is weak, then what happens? Then what happens? Just tell me
I'll
that
easily
this, one second, right? If this bond is weak, so only two molecules or three molecules on this side and two, three molecules on this side will be sufficient to break the HCl molecule, or I will say to break one molecule of HCl. Are we understanding?
yes, ma'am.
But so let's say, just consider the fact that let's say five molecules of water are utilized, according to this example, are utilized to break one HCl molecule. Let's say like that. And let's say if I add 100 HCl molecules, yes or no? And water molecules, what do I have? I have 1000 water molecules inside the beaker. That means I have taken water by 1000 H2O. Understood my point or not?
Yes, ma'am.
So now here, what exactly happens? Just tell me. When we have 1000 H2O molecules and we have 100 HCl molecules here, what does that mean? So I'm going to say that when we have 100 molecules of H2O that is utilized to break one HCl molecule, got the point? So what
Yes,
does
ma'am.
that mean? Just tell me. What does that mean? That whenever we have 100 HCl molecules here, right? So every molecule of HCl is requiring 5 H2O molecules to break it down. So as a result, 500 water molecules would be utilized. Are we understanding? Why
Yes, ma'am.
500 water molecules? Why 500 water molecules will be utilized? Because every HCl molecule requires 5 H2O to break it down. And I have
Yes,
taken 1000 H2O. That means this water is sufficient to break the molecules bond. And hence I'm expecting that if I have added 100 HCl molecules, so out of 100 HCl molecules, what exactly do you think is going to happen? We will have 100 H plus and we'll have 100 Cl negative. Are we understanding this part or not?
yes, ma'am.
So
Yes,
that's the
ma'am.
point. That's the point. So I hope you're understanding that whenever we have 1000 H2O, so out of this, and why is that? Why very less quantity of water molecule is able to pull apart HCl? Because HCl's bond individually is quite a weak one. Is
Okay.
quite a weak one. Are we understanding my point or not?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Now understand. So this is happening. Got the point? Now what exactly happens? Let's say I take CH3 COOH. In this structure, O carries a negative charge and H carries a positive charge. Why? Because O, if you understand in a very, very basic term, O has an atomic number of 8 protons and H has an atomic number of 1. So whose protons are more? O. Also, the overall impact of the nuclear charge in the radius of oxygen is more than that of hydrogen. Yes or no?
Yes, ma'am.
So if I say CH3COOH, what does that mean? That, ma'am, in this molecule, again, if I take 100 molecules of acetic acid and I put it into water, and let's say 1000 molecules of water, and let's say 1000 molecules of water. Yes or no?
Yes, ma'am.
So when I have 1000 molecules of water, what does that mean? That for one CH3COH, let's say, again, obviously O negative will be attracted by H positive of water. H positive of water. Yes or no?
Yes, ma'am.
And H positive shall be attracted by O negative of water.
Yes, ma'am.
Are we understanding?
Yes, ma'am.
So here, because this OH bond is very, very strong, this OH bond is very strong. So then what is going to happen? That it will require, let's say, let's say 10 molecules of water on this side and 10 molecules of water on this side. And then this bond is going to break. And when this bond is actually going to break, what does that mean? That now one CH3COOH molecule requires 20 molecules of, or I will let me increase the number, 20 here and 20 here, requires 40 molecules of water on both the sides overall to break the bond of OH. And then, so thereby you understand, so 1000 molecules of water I have, 40 molecules of water are required. So basically, by this ratio, I will be able to break only 25 CH3COH molecules. Are we understanding or not?
Yes, ma'am.
And when we are breaking only 25 CH3COH molecules, what does that mean? When we are breaking only 25 CH3COH molecules, what does that mean? That clearly means what? That, ma'am, whenever this is happening, yes or no?
Yes, ma'am.
So that clearly means that whenever we have 25 CH3COH molecules breaking up, only 75 molecules are still left and they are not breaking down. So you tell me whose constraint it is. Is it our constraint or is it the molecule's constraint? So
Uh,
it is our constraint. If
yes,
we would have added more water, we were more likely to break the molecule, right? Yes or no?
yes, ma'am.
So if you put this 100 molecules of CH3COH in, let's say, swimming pool, highly likely this is going to dissociate completely because that's a case of infinite dilution. Are you understanding my point or not? Because that's a huge
Yes,
amount of water, a huge amount of water molecules which is trying to pull apart CH3CO negative and H positive. Are we understanding?
yes, ma'am.
Got the point?
Yes, ma'am.
So that's the basic idea. So that's the basic idea. So you understand that whenever we are dealing with the OH bond, which is very, very strong, and we have this, so what does that mean? That, ma'am, whenever we are dealing with this part, OH is there, OHH, OHH, yes or no?
Yes, ma'am.
So then we say, now why I'm calling this, because when in laboratory we perform certain experiments, what exactly happens is that we take the reactions in the beaker, in the test tube. And when we take it in the test tube, what would that mean? When we take it in the test tube, what would that mean?
Fixed volume.
The amount of water is very less.
Yes, ma'am.
And that is not able to break all the strong bonds. And as a result, in the test tube, that electrolyte acts, even in the form of a beaker, this electrolyte acts as a weak electrolyte. Got the
Yes,
point?
ma'am.
One thing
Yes,
is
ma'am.
this, right? Now, first of all, you understand that. Now, secondly, you understand whenever any reaction, specifically electrolysis, when you talk about, I'll give you a very brief outcome of this. So you have this beaker, right? I'm not explaining electrolysis, just a quick briefer, because then you'll understand what I'm trying to talk about. So these are the two rods, which we call them as electrodes. And this is nothing but what? This is nothing but this is the battery. Yes or no? This is
Yes,
my
ma'am.
negative terminal and this is my positive terminal. So when we are dealing with the electrolysis part, what does this part mean? So when we are dealing with the electrolysis part, we know that we have added some liquid here, and that liquid has to be some electrolyte. That means it is, let's say, Na plus and Cl negative. Are we understanding?
Yes, ma'am.
So one, if it is Na plus, and second, if it is Cl negative, What does that mean? What does that mean? That Na plus, because NaCl is a molten liquid and that is trying to break down. So that is going to break down into Na plus and Cl negative. So I hope you're understanding. Na plus goes here and Cl negative goes here. Are we understanding?
Yes, ma'am.
So you understand what is this battery doing? Every battery acts as a pump, right? What
Yes,
does
ma'am.
a water pump do? Tell me. What does the water pump do? Water pump takes out the electron. Water pump does what? Water pump takes out the electrons. Or water pump does what? Let's say we have a house, right? So in the
Yes,
house,
ma'am.
what exactly happens? There is a tank here on the outside and there's a ceiling on the top of the floor, on the stairs or in the top. What do we have? Here we have a water tank. And once we turn on the water pump, what exactly does that do? It pulls out the water and takes it to the topmost tank. Yes
Yes,
or
ma'am.
no?
Yes, ma'am.
So when that is happening, when we have the water flowing here, yes or no? When we have the water flowing here, what does that mean? That ma'am, this water is being taken here from lower to higher. So similarly is the case of water pump, this elect battery. This battery basically does what? From this rod A, it is going to pull out electrons because obviously this rod must be made up of something which must be containing some atoms, right?
Yes, ma'am.
And when it contains certain atoms, it would mean what? When it contains certain atoms, it would mean what? It is going to pull out the electrons from here. And when it is going to pull out the electrons from here, so these electrons will be taken out and they'll be filled in the rod B. Right. So when this is happening, what does that mean? Just tell me. What does that mean? So from here, the electrons will be taken out, and here the electrons shall be filled in. So this rod A will acquire a positive charge because from this rod, most of the electrons have been taken out, and the second rod B acquires a negative charge.
Yes, ma'am.
Yes or no?
Yes, ma'am. Yes, ma'am.
Now, this is the external circuit. This battery works as an external circuit. This battery works as an external circuit.
Yes,
Once
ma'am.
this battery works as an external circuit, so Na plus will go here
Yes,
and
ma'am.
Cl negative will go here. What will Na plus do? Na plus will go and hit the rod. Na plus will take one electron. Now
Yes, ma'am.
understand. See, there is always a limit to something. You cannot keep asking for money from somebody. Someday or the other person will say, okay, I do not have more money to give you, right? So there is always
Yes,
a
ma'am.
limit. Similarly, from rod A, how long do you think that you can keep on asking and keep on removing electrons from this? There is a limited storage of electrons here. From that, as many electrons you can pull out, you're putting it. Over a period of time, it will be very difficult to pull out some extra electrons from the rod A.
Yes, ma'am.
And similarly here also, from B side also, it will be very difficult to pull out electrons to give it more electrons. I'll tell you why. Because let's say after giving it 100 electrons, let's say the 101st electron tries to enter. So do you not realize that this rod B has already become so negative that this negative charge is going to repel this incoming negative charge?
Yes, ma'am.
And as a result, this incoming electron will not get an entry in the rod. Also, if an extra electron wants to come out of this rod A, the positive charge is going to pull back this negative electron. Are we understanding?
Yes, ma'am.
So what does that mean? What does that mean? Tell me. That we have
It's
a
going to.
rod A, right? We
Yes,
have
ma'am.
a rod A and we also have a rod B.
Yes, ma'am.
So what does this rod A and what does this rod B do? A tries to give electrons, B tries to accommodate those extra electrons, thereby B acquires a negative charge and A acquires a positive charge.
Yes, ma'am.
And A acquires a positive charge. As a result, what exactly happens? Yes or no? As a result, what exactly happens? We have this,
Yes, ma'am.
but this is the external circuit. But do you realize that the external circuit will work for some time and it is going to then stop? Why? Because it cannot keep on giving more and more electrons. Are we understanding?
Yes.
Now,
Yes, ma'am.
similarly, what is happening? What is happening? So we will have this Na plus. This Na plus shall do what? This Na plus shall go, will reach the rod B, and these ions are going to complete the inner circuit. And if the inner circuit is complete, then the entire cycle is completed. Okay. Then the entire cycle is complete. Now, how is that entire cycle complete? Just see. The Na plus goes here, pulls out extra electrons. So it takes that electrons and it becomes Na solid. So
Yes,
if you
ma'am.
keep removing electrons from rod B, the more and more electrons can be given to it again and again. Because once you're giving it from the top, it is being removing from the bottom to Na plus. Are we understanding? As a
Yes, ma'am.
result, what is Na plus getting? Na plus is getting the neutrality. Na plus is gaining that neutrality, and that's what it is running. That is why it is running towards the rod B. Similarly,
Yes, ma'am.
when we let's talk about the Cl negative, what does Cl negative do? This Cl negative will exactly do what? It rushes towards the rod A, and Cl negative means it is rich in electrons.
Yes, ma'am.
And because it is rich in electrons, yes or no?
Yes, ma'am.
So this Cl negative will give electrons to this rod.
Yes, ma'am.
And because it can give electrons to this rod, so this positive charge will become neutralized and Cl will also become neutral. So now do you understand that if I'm continuously taking out electrons from rod A, but I'm also giving it in the form of Cl negative. So Cl negative is also becoming neutral. You understand? Cl negative is also becoming neutral,
Neutral.
as well as it is also becoming neutral, and also what it is doing,
Na plus is also
it is
becoming.
also giving electrons to rod A so that battery, the external battery, can keep pulling
Yes.
out electrons, keep putting it in rod B. So
Yes,
now
ma'am.
you understand why the movement of these ions is so important. Let's say if these ions would have moved very, very slowly, then very slowly, Na would have reached the rod B. By then, there would have been a chance that this battery must have suffered a short circuit. Why? Because if Na plus doesn't reach the battery, the rod B on time, you are not able to pull out electrons. And the battery has given more electrons here to enter inside.
Yes, ma'am.
Are we understanding?
Yes, ma'am.
So I hope you're understanding what exactly does that mean. That clearly means that, ma'am, whenever we have this kind of scenario, the ions must be moving at a very high speed so that the internal circuit is complete so as to make sure that the outer circuit does not undergo short circuit. Got the point or not?
Yes, ma'am.
Now, on the similar note, now there are two things. One is called conductivity. On a very simple note, just remember that conductivity has got nothing to do. Conductivity means 1 ml solution in chemistry. So whatever number of ions come in 1 ml solution, right? They will their movement will decide the conductivity. One thing is molar conductivity. Molar conductivity means the presence of 1 mole salt.
Yes, yes, ma'am.
The presence of 1 mole salt. 1 mole salt which is dissociated into its ions.
Yes, ma'am.
Got it? Which is dissociated into its ions. Are we understanding my point?
Yes, ma'am.
So it says molar conductivity, the presence of 1 mole salt dissociated into its ions. Are we understanding my point or not?
Yes, ma'am.
Now see, understand. So when we deal with the conductivity part, now understand. Let's say if I have NaCl solution and I take, let's say, some amount of water. Now also understand one very important part. Let's say if I take water, these are black are water molecules, okay? If I add salt into it, you understand that salt goes into the spaces between the water molecules, yes or no? Salt
Yes, ma'am.
goes into the spaces between the water molecules. When salt goes into the spaces between the water molecules, what does that mean? Tell me. When salt goes into the spaces between the water molecules, what does that mean?
Ma'am, it will
Tell me.
get dissociated.
So that means the volume is not rising. But let's say I have added 4 moles of salt in 10 liters of water. So you understand that basically in 10 liters of water, we have 4 moles of salt. So in 1 liter water, we'll have 0.4 moles of salt.
Yes, ma'am.
So in 1 liter water, we're going to have 0.4 moles of salt. Yes or no?
Yes, ma'am.
Okay. Now, 1 milliliter means 1000 ml. Now, let's say I have a spoon, and in that spoon, I have taken 1 ml solution. So when I have taken that 1 ml solution, obviously there must be some ions in that solution in 1 ml. Whatever value of conductivity is present or is calculated for those ions present in 1 ml of solution is called conductivity, which is denoted with sigma. Are we understanding? Or that is also called as kappa.
Yes, ma'am.
Got it?
Yes, ma'am.
Now, so there are two factors on which it depends. Now tell me. Let's say, let's say I dilute the solution. So when I dilute the solution, that means I add more and more water to it. So when I add more water to the solution, what do you think is happening? Earlier, the same 4 mole salt was present in 10 ml. Now the same 4 ml, 4 mole NaCl salt is present in is present in 20 liters because I have added more water. Got the point?
Yes, ma'am.
So point basically is what? So we have 20-liter solution. Now in 20-liter solution, what exactly happened? मुझे बताओ. We have 4 moles. So basically in 1 mole it is going to be 0. What
0.4.
is it? What is it going to be? It's going to be 0.02 moles per liter.
Yes, ma'am.
So you tell me 1 ml, how much ions will be there? 0.02 divided by 1000? Because 1
Yes, ma'am.
liter is nothing but 1000 ml. And earlier we had 1 liter had 0.4 moles. 1 liter had 0.4 moles. Yes or no?
Yes, ma'am.
So we had 0.4 moles per liter. And
Yes, ma'am.
thereby, that is nothing but 1000 ml will have 0.4 moles. So 1 ml will have 0.4 divided by 1000. And that is 0.0004 moles.
Yes, ma'am.
What does that mean?
And the particles are spacing out when diluted.
Exactly. Now from this solution, so basically now if the molecules reduce, their ions also reduce.
Yes, ma'am.
Their ions also reduce. And if their
Yes, ma'am.
ions also reduce, what would that mean? If their ions also reduce, what would that mean? That per ml, if the number of ions are reducing, obviously the conductivity will decrease. Because one simple rule, if the number of ions are more in 1 ml, obviously the more ions will be able to move freely. More the ions, more is the conductivity.
Yes, ma'am.
So if in 1 ml solution, the number of ions, if they're decreasing, if they're spacing out, what would that mean? If in 1 ml solution, if the ions are spacing out or if the ions are if the ions are reducing,
Ma'am, conductivity is reduced.
conductivity reduces. Got the point? Because conductivity is nothing. It is the movement of the or conductance of the electrons or the ions present in 1 ml of the solution. It is the
Yes, ma'am.
conductance of the ions present in 1 ml of the solution. Are we understanding this part?
Yes, ma'am.
That is, and also second factor which affects conductivity is temperature. If you increase the temperature, obviously the kinetic energy of the ions will increase. And because the kinetic energy of the ions will increase, because the kinetic energy of the ions will increase,
Conductivity will also increase.
conductivity also increases. Got the point?
Yes, ma'am.
So that's the basic idea. Understood or not?
Yes, ma'am.
Okay. So that's how we have. That's it.